When I thought about making this presentation, I thought that, it's really a long time ago that I really worked as an active programmer, and a lot of things I've forgotten all about it. So nowadays I just do programming for my own amusement, which is nice because when it doesn't work, you don't have to worry about it. Anyway, I thought we'd start off by talking about a little about the history. That this is the early days of Erlang. Now we're going back to the late 1990s, and we really have to go back before that. I think many people haven't realized why Erlang was invented. That Ericsson had at one time a very successful product called AXE. Now, AXE really earned billions of krona, dollars, or whatever for Ericsson. It was an incredibly successful product. It really almost wiped out the market with other types of telephone switches. And as it was developed in the 1970s, it was started in the technology which was available then. It was programmed in a programming language called Plex, which is, as you kindly said, is a sort of concurrent high-level basic, maybe even low level than that. The thing that you get with telephony and all kinds of telecommunication systems is an enormous amount of users working at the same time. So you need massive concurrency. You have to handle massive numbers of telephone calls. The situation gets even worse when you get onto mobile systems, because in a normal telephone call, an old-fashioned exchange, you basically just had to set up a connection and that was that. But in a mobile network, you're actually monitoring the reception from mobile phones continuously, cellular phones continuously, and actually sending them information about how hard the output power. You're sending them information about when they need to switch over, hand over to other base stations, and this sort of thing. So the concurrency is really massive. The AXE was developed as a successor for a system called AKE, which was programmed in assembly language, and they had massive problems with stray pointers, as you would get in that sort of language. It's even worse programming in assembly language than it is programming in C. And the thing about AXE was that it had MMU protection, that so that one call could not crash the whole exchange. It was modular, in that you had what you call blocks of code, and it was supported by in hardware by specially designed processors. The processor actually supported concurrency, and it also did have the advantage that you could change code on the fly. These were basically the prerequisites which came into Erlang. This is what we were told to sort of emulate, to do the same thing. But it had some disadvantages. One of them was it was directly proprietary. Every time you wanted to sort of employ people, you had to teach them Plex. It was very costly to program. That the normal metric we used, that it cost 2 hours to program one line of code at the end of the day when it was out. It was expensive to support because you had to have your own development environment. It was expensive to have to develop your own processors. That these are before the days of microprocessors, and of course when microprocessors turned up, they were incompatible with Plex. You had to train your own program processors, and it couldn't use distribution, which was a major problem because every time you wanted to reach capacity, you couldn't just add on processors. So this is what was really behind the back of our heads when we started the computer science lab. That Bjarne Decker started the lab. I was one of the first employees at the lab, and the mission was find a way to program something like AXE with all its advantages, but use commercial processors and more modern software technology. Fred, next slide, if you would, please. Yeah, well, so there were two projects started off. There's all sorts of history here, which I won't go into, but one of them was Erlang, and we developed a current new functional language. the idea of functional programming and using that for telecommunication came from one of the other guys in the lab called Nabil El-Shevi. He was the first one to actually do functional programming, but it was jumped on by a lot of people. At that stage, I think we were very into logic programming, but we realized that functional programming was better, which is why we sort of, Erlang became a sort of weird mix of logic programming with something weird, almost like logic variables and functional programming. A standard processor and a standard operating system that we first started on VAX VMS, where it migrated to a lot of other operating systems. And nowadays, I think Linux is the operating system of choice, but not necessarily have it. But at the same time as this was being done, another group of people tried to do the same thing, but they started doing the other way around. They said, let's have a standard language. But they realized that if you wanted to get the sort of MMU protection, changing code on the fly and all the rest of it, you had to have your own operating system. So they invented an operating system called DCOS, and they used standard processors. So both of them were sort of non-mainstream, both of them proprietary, Ericsson. One of them used his own language, the other one used his own operating system. So Erlang began to be used in several key projects. The first big one that people still talk about was a big ATM switch. ATM was a transmission technology which is best nowadays forgotten, but it was what we thought was going to sort of take hold before the internet arrived. And it also began to use, and it is still being used today, as the interface from mobile cellular base stations to the internet, the information for that. But there was a problem. The management were worried about the cost of Erlang, and what they actually were worried about was the cost of having your own language. That this is what they'd seen, that in the AXE had both its own language and its own operating system, but somehow it was the language which people focused on. And they brought in some people from the outside and who had already committed to using technology from a company called Rational, which has later days been bought up by IBM. And Rational Rose RT. And they were already committed to using it, and they thought this was the way to go. It was hard to recruit programmers to program in Plex. They thought, well, maybe it's going to be just as difficult to recruit programmers for Erlang. So they actually banned the use of Erlang for a new project in February 1998. And this resulted in the fact that they said, well, we've got Erlang here, what should we do with it? They weren't actually saying the ban was permanent. They said that if you can actually show that it can be used and we can recruit programmers, we'll start using it again. And we said, how do we go about that? And there was a lot of sort of whispering in corridors and all the rest of it. And eventually it resulted in Erlang being released as open source in December 1998. Which is actually, when you think of it, is now 23 years ago. Several key people got really pissed off about Ericsson and the ban and started their own company called Bluetail. And we'll get back to Bluetail later. It was a very successful company. And some projects have mainly for charging systems started being made for charging, that is charging money, not charging batteries. Started being used based on the DCOS system. Next, please. Well, what happens when you try to market a software technology? That what people don't actually know, and I'm also ashamed to tell you about, was that I was actually for a time the CEO of a company of a subsidiary company to a subsidiary company of Ericsson called Erlang Systems. Erlang Systems Aktiebolag being limited in the Swedish terminology, and my job was to sort of go out and try and sell Erlang. I sold Erlang to one client who I think you maybe have heard earlier in this conference. Ulf Viger was my only customer. which I still thank him very much for. I can't remember whether he paid anything for the system, but it certainly wasn't very much. So you came to the conclusion you can't make money selling software technology. You can't do it, but you can make money by using software technology. And that's a very important distinction, that you can make money by selling consultants, you can make money helping young people, you can make money possibly by tools, doubtful if you make money by tools, but you can't make money in the technology itself. It's the infrastructure and everything around software technology and the products you build. That's where the money comes in. That one of the people, incidentally, that we employed at this stage to try and into the company Erlang Systems was merged into a department in Ericsson, or another part of Ericsson. One of the people that we actually employed was Francesco, sitting there. He was actually employed by Erlang Systems. So all he had to do when he left was change the word systems to solutions, and Bob's your uncle, he had a company. Well, possibly it wasn't quite that simple. That we had a good take-up of Erlang universities, that we sent out tapes at this stage because we didn't have the internet. We sent out, I think, Bjarne would tell you how many tapes it was we sent out, but it was hundreds of them. And we had, I remember a contract, the legal people wouldn't touch us because they thought we were unnecessary. So we wrote our own legal contract for selling it. And I remember we copied a contract which came from Berkeley in California, which was talking about software developed under the laws of the Republic of the United States. So our contract said that we published this software under the laws of the Kingdom of Sweden, which I don't know whether that was legal or not, but we had good fun. I traveled around a lot of big companies to try and interest them in Erlang. I traveled down to Sun Microsystems. I sent to HP. I traveled around with the then person who had taken over as manager of Erlang Systems, Roy Bengtson. We went to HP, and they didn't like us. So that after talking to them for half an hour, we found us standing on the pavement outside HP in California, saying, "I wonder why they didn't like us. We obviously trod on some sore toes there." IBM were interested, but they just couldn't see how they could make any money out of it. And the mainstream, which you can say, big companies, the mainstream is powerful. That's it. Big companies will go for the mainstream. Well, what happened after we released it to open source? Erlang's open source. We started a company, Bluetail. It was successful, and it was sold to Altium for 152 million US dollars. The unfortunate thing was that it was sold as shares in Altium, which were transferred to shares in Nortel, which possibly was not a very good thing to happen for the people that had those shares. Nevertheless, Erlang, the Bluetail, successfully was sold. Then with this new startup, TailF, started a very successful company in the finance sector. It's called TailF because you know the Unix or Erlang or the Linux command TailF. You can look at the end of the file. That when they were actually Klarna started using it, they actually worked out how much money are they making. So they should TailF command on the log file. They could see the transactions ticking in and what was happening. That was sold to Cisco for 175 million US dollars. So that Erlang certainly took off that way. And it's sort of, I don't know what products Erlang has been used for nowadays. It's betting. Bet365 is an interesting version. It's not exactly what we had thought Erlang would be used for. WhatsApp, people know that it was sold for a vast amount of money to Facebook. Unfortunately, Facebook have changed the licensing rules for that, which I disapprove of, but that's not really part of this discussion. Telorb, what happened to that? Well, it actually worked, and they made some products, and they sold some products, but they soon realized that actually having a proprietary operating system is worse than having a proprietary language. The proprietary operating system means you have to port the thing to a new operating system every time the operating system changes. But what's worse than that, you have to, every time the processor changes, you have to do a port. And that, later I'd moved out of Erlang Solutions, then I'd moved into another position. And I traveled around to the same companies again, Sun, Sun, HP, and IBM, and tried to sell Telorb with the same spectacular lack of success. However, we're getting a bit of track, and you don't really want to listen to too much of an old fogey talking about what he did once upon a time. Well, what's the morals of this story? Well, if you're not mainstream, you can't really sell anything very easily. It's difficult because you need a reference, and you can't have a reference without having got it, having sold it somewhere, getting the technology to work somewhere. So it's a chicken and egg problem. So getting a new technology in is difficult. It's easier nowadays than it was because there are a lot of very good references and you can show people. Without those references, it's very difficult. You have to show the technology works and is reliable. And there again, references are the best way of doing it. And you have to show that training people is remarkably easy. That Erlang Solutions have given a lot of courses now, and I think that the experience of that is that teaching people Erlang is not difficult. In fact, the difficult thing, as I think about it, is actually not learning the language, because Erlang is actually a trivially simple language to learn. If you want to learn anything, the difficulty, I think, is more difficult to understand how to use OTP, which I think is actually much more difficult to understand. You need at least one enthusiast in the group of people you're trying to sell Erlang to. If you have people who are trying to sell it to a group without anyone with no experience, it's very, very difficult because people are static. They don't really like change. And you need to be able to get management to listen. And if you don't have that person there who is able to be enthusiastic, tell people that it works, management are going to say, oh, let's do it the easy way. Let's use what everybody else uses. Once upon a time, when IBM machines were the sort of main thing in computing, so there was the statement that people said, no one ever got fired for buying an IBM machine. Nowadays, you probably would get fired for buying an IBM machine, but that's another story. If people committed to another to technology, as we had when we were trying to sell it with the Rational Rose business there, it's very hard to get them to change. There's all sorts of reasons why people are committed to that. They may have an agreement of friendship with consultants, or they might be interested as the people that are supporting that technology, or they might have subcontractors. There's a large number of reasons. And if you try to sell something in and you meet resistance with alternative technology, you have to dig in to find out why is it, what is it that is causing the blockage. That people who are uncertain, well, they'll tend towards the mainstream. A lot of management, managers in large companies who make decisions are not actually programmers themselves, and consequently they will make decisions based on what other people are doing. And you must be very clear about what your technology solves, and you must be able to explain it to non-software people. Explaining the fact that you need the language concurrency is very, very difficult to people that don't know what concurrency is. So you have to sort of go down to the very basics of why things work and what they are. Fault tolerance is an interesting concept, but especially fault tolerance from software bugs. When you have to explain to people, yes, there are software bugs. No, we can't test away everything. Nothing will ever be perfect. If you actually have a project which is already started with a large code base, it's almost impossible to get in a new technology unless they're doing a complete rewrite or something like that, because they're so committed. There are some people have, once you've dug your heels in and got millions of lines of code in something, it's not easy to put in a new language or new technology. The main thing is, and I think the one thing I learned trying to sell Erlang unsuccessfully, is you should concentrate what's good in what you're proposing, and try to avoid attacking what people are using now. You shouldn't say you should use this because what you're using now is bad. You should say you should use this because what we need to propose is better. Well, that's about a bit of my story, what happened and why things are. I think I'll hand over to Fred now, and he can tell you his from a slightly younger perspective, I think.
Right. So, younger perspective, and also a bunch of smaller companies. But as you'll see, the parallels are pretty much the same in a lot of them. In my case, the thing I really want to start with, and this is possibly the most important point in my section of the talk, is going to be to figure out what the disguised no's are. And the disguised no's, I don't know, it's a sort of term I came up with because it's a thing that I kept seeing happening over and over again in a lot of companies. When you're on the inside and trying to get them to adopt the technology, what you might get a lot of is a bunch of concerns, and they're going to be valid concerns. Is it going to be fast enough? Is it going to be maintainable enough? What are the tools around that? Is it going to fit within the team? And they're all really, really valid concerns that you can take a lot of time to tackle them, to convince people that actually it's going to work and it's going to be fine. But the problem with the disguised no is that behind these concerns, there isn't an actual yes that's standing behind them. It's still a no that is sitting there. And Mike hinted at that. A lot of the decisions are deeply personal. And when we get a feeling for something, we tend to rationalize that feeling in all sorts of ways. And it's possible that someone hates Elixir, hates Erlang, hates a piece of technology, or very much likes what they have right now. And anything that comes and could be replacing it is a sort of threat. And so what you come up with is these explanations of, you know what, it would be great as a technology, but I like this thing very much and it does this. So can you prove me that it can be as good as some of these things? And it creates these sorts of never-ending lists of challenges that is going to be really, really hard to replace. And you have to identify the real underlying concern, the personal thing that the person has behind it all to be able to have any traction. Because unless you do that, the thing that's going to happen is that you're just going to get thrown more and more and more and more challenges on top of what you're already doing for your work tasks, and you're never guaranteed to make any progress. So one of the interesting things to do is to, work with the people in a leadership position, whether it's technical or management, and figure out like, what are your concerns? Get a list of them. And then you can sort of ask a question like, if we are able to address all of these, then what? Is this going to move forwards, yes or no? And one of the things that might happen is just that you're going to be told, no, I actually don't have the deciding power to be able to do that. And what you find out is that you have this list of work that could take years to get through, months if you're lucky, or weeks if it's really, really simpler. But even having all the answers to all the questions and all the concerns doesn't guarantee anything unless you have identified that underlying concern, and tackling that one directly can be a lot more effective. Once you're having these discussions, it's also interesting to really ask a question: what is it that you like about our existing setup? What are the things that you're afraid we're going to lose, or something like that? And this question is interesting because, for one, it shifts the perspective a bit, but also because it forces the person who's making these rationalizations, and it would be, if it's about getting rid of Erlang, it would be me making the same rationalization, asking these questions. Will highlight sometimes how personal it can be, or some of the aspects of there, or in some cases it's just, it's what I know and I don't like the change that much, and it can actually open up the door to actual discussions about bringing change in a company and an organization, because you might realize that actually I might not like this as much as I thought I did, and then it creates an opening. But you have to identify this disguised no's, because they're going to be a huge time and energy waster, and could cause burnout in a few people if you're not careful about that. I'm going to get back to the theme of going against the mainstream that Mike has mentioned. Really, going against the mainstream is easy if there is no mainstream, right? You're going into a new area where there's nobody really operating there. There's no prior art or very little of it. And so using the new tech can be a sort of secret weapon. There's nobody to be able to dislodge you, and the technical aspects become leverage right away. If you're fighting the established players in their arena, it's going to be a lot more tricky, mostly because your costs are always going to look worse. From the simple point of view that a lot of libraries and knowledge is floating around, and you can't as easily borrow, use, exploit that, or just build on it. And so unless your team believes that you're world-class people that don't have to look into what the rest of the world is doing, fighting the mainstream is going to be harder. And so when it came to adopting Erlang in my career, and that I've seen the same with Elixir, this sort of stuff is still at play. The easy cases were sort of easy-ish 10 years ago, and they're a lot rarer, right? Back then, you wanted to do something with concurrency, you wanted something to do with distributed programming, there was nothing. You used Erlang because it was the only thing that could do it. There was no argument to be had. If you made a list with the box to tick, it was like the only thing that could ever do it. The world has caught up. And so that easy cases where nothing else could ever do it is no longer the same. Go has made inroads in some of the approach. Rust has done it in others. If you're using .NET, C# has promises and futures and all of that. The Scala, the JVM ecosystem, all of them got a solution. They're not necessarily as good, but what they do is that they make it a lot less obvious that there's any technical superiority to what Erlang is doing to people who are already invested in another piece of technology. So early on, it could be easy to say like, oh, we want to do it at a scale that nobody's doing it. We're using the tech that's going to do it. It's not that obvious anymore, right? There are still advantages, but there's not a slam dunk. The ecosystemic difference and effects are also stronger. It's like everyone's moving to Kubernetes. There is continuous integration and deployment, containers, all the utilities and the dev tools that we have are getting standardized. And what's interesting about that is that if you have this immutable infrastructure, it locks you out of some solutions. Some things like Kubernetes with containers instantly means that you don't get hot code loading anymore because that's not the way it's done. And so the advantages that you could have in the solution now become costlier to apply than they would be on their own. There's an interesting discussion starting with the Erlang Ecosystem Foundation build and packaging tool about how could we bring real-time upgrades into containers and force things to be mutable as an option. But that effort has to be done because it's not one or the other. Now it's, if you want to do that, you have to also give up all the entire tool chain that exists everywhere else. The same is true of SDKs, APIs, and stuff like that, where the documentation is going to be existing in mainstream language. Python, Go, C is going to have them, Java is going to have them, Elixir and some service providers. But in a lot of places, it just, if you're using a third-party service to save time, you're also paying the cost of integrating with them, which you don't necessarily pay with mainstream technology. And so that gets harder and harder as everything has been shifting to a kind of web service economy for that stuff. And the libraries to plumb things together has that same effect, where someone has to write the library and has to open it up. And in a large ecosystem, you will find that through sheer amount of bodies thrown at the problem, you get some mature solutions. In a smaller ecosystem, the thing you have to assume is that you're going to use a library that's been written for the use case a person had, and you will need to adapt it to your use case and add the maturity to it that didn't exist. And only the very, very core stuff is going to be done more solidly. And you have to be aware of these effects that increase the perceived cost of switching. Then there's this idea of commoditization, right? Commoditization is being a woodworker is nice. You get very, very high quality stuff, but it's probably a lot cheaper to go to IKEA and just buy your shelf and assemble it. And it's going to be 10 times cheaper, 10 times faster to do it that way. When it had to be with writing infrastructure for the components because you were scaling something like RabbitMQ, the Beam virtual machine and the technology itself provides huge advantages. But once again, the ecosystem has shifted in some ways where a lot of products being built no longer need to write their own infrastructure anymore, right? You get them from services that you pay for. And so this forte of the platform has eroded a bit. And so once again, it doesn't mean that the tech is not good. It just means that the arguments are a lot harder to sell anymore because you can pay not to have to worry about that. And again, the ecosystem effects remains the same, right? Training for me is the hiring concerns. This is what they're all about. It's expensive to find new people, train them, get them up to speed. Or at least it's perceived to be expensive, right? I believe it's more expensive not to do that, and we tend to do it all the time. If you pick a mainstream technology, the sort of assumption is that you hire someone who's already been trained by other participants in the ecosystem. You're paying a market rate, you get someone competent, and then you don't have to care about it. And this is a really, really hard idea to undo. The idea that, you know what, we're going to take, like, if you're joining a new company, it's possible that you won't be really productive before 2 months, 3 months, in some cases, even 6 months before you're actually productive. And it's assumed to be sort of normal. And it's interesting to ask a question like, what happens if we take the 2 months it takes for someone to be productive and we add 2 weeks of that to train them and then keep the training as a muscle we build as an organization? But that's a really, really tricky discussion to have and sell people. Libraries and free support come from that, right? It's just nobody's paying the cost, and it's about people volunteering in their free time producing it and making it open source and doing it for free, and then companies swoop in and get all of that. And when you are not the mainstream, you have the issue of having to, you can't commoditize as hard. You can't just reap what other people have sown as hard, and you have to bear some of that cost. And this is going to cause a lot of concerns in all sorts of discussions. Personally, I found it easier to sell people on the idea that it's actually good to do these things regardless of what technology you use, which then lowers the bar to getting the non-mainstream technology, than it is to just convince them that actually the cost is going to be low. Like, we have to pay that cost. We should be paying it with a mainstream technology. Let's try with a short with an experiment. Seems to work somewhat better in my limited experience there. And then once you have that opening of let's adopt the new incumbent technology, not the incumbent, but the new challenging technology, Erlang, Elixir, whatever it is, it might be Rust as well if you really want, then you have to choose which project to apply it to. You can't pick any random project. There's difficulties that come with each of them. The easy projects are going to be, once again, nobody operates in your space. Everything has to be written from scratch. Really easy to do because the cost is high no matter what. The small project without too many implications otherwise is the easy one, because there's a perceived psychological safety for a team or a company to say it's just a small project. If it's not bad, we can cancel it and rewrite it, and it's not too costly. And so those are really, really easy to get your foot into the door. And one of the limitations there is that the projects never move past that phase of small and easy. So then you need to get into the moderate projects, which is a bit trickier. You start having to pay the cost of all the adapters for the existing ecosystem. You will want to focus on the low risk, high reward projects. If the project has a budget of, I don't know, $500,000 or $1 million, but can only bring you like 10% profit if it's successful, you're almost guaranteed your project is going to fail no matter what technology you use, because there are always surprises. If it's something where you invest $1 million, but you know it might save you $50 million, you can use almost any piece of technology and be successful because you're allowed to make like 5 times the project worth of mistakes and still come up on top. So if you can identify these, they're ideal projects to do that because they're a lot harder to fail. And you have more time to make your mistakes, to rework them, and there's always going to be a business benefit to doing them regardless of the technology you use. Mostly greenfield projects, still kind of interesting again for that. It's fitting with the rest. And if you have people ambivalent about existing tech, as Mike has mentioned, you don't want to be spitting on anyone's technology. But if you're an engineer, you have a feel if people hate the tech they're using right now, right? You might be like, oh, this JavaScript thing is really painful. People were very, very tired about a lot of the C++ or C quirks around security and safety and all kinds of things, and the compile times. And so shifting to Rust has been easier because people are more readily available to switch and learn something else and improve their situation. If they love the technology, it's never going to be a moderate project because you're going to have to fight for the buy-in. So the hard to impossible projects, those that I think a younger me has tried to switch and I wouldn't try anymore because it's not worth the energy, it's probably those in a saturated space with no advantage to the new technology. You're going to argue against a mainstream that's extremely commoditized with a lot of available people and a lot of available knowledge for a difficulty that brings almost no benefits to anyone. Razor thin margins, it's the counterpart of medium one. If there's a project and you have like 5% of the budget is what you could stand to make out of it, you have no margin of maneuver. You're almost guaranteed to kill the chances of your tech with mistakes that have nothing to do with it. If you have existing expertise with significant existing code bases, like there's knowledge floating around the company, and that knowledge may or may not be interested in switching to your new language, you have this challenge as well. Like having the domain knowledge required is a major part of what makes a business work or fail. It what makes a team successful or not. And if you can't count on it, it's going to be really, really, really difficult to get any traction whatsoever. So if you can't get it, you have to build it. And if you don't have it, I would say just don't try. It's not worth the effort. You're going to burn yourself out for no reason. So the core thing to me is that you have to build from the grassroots. If you go to any airport, or you used to go to any airport and you went into the places that sold book, like half the book pyramids in there are about management and how to get people to do the things you want them to do. Managers don't have the key to making employees do what they want more than you do. Mostly they're dying to find ways to get the alignment like that. If you can build it and show up with it already, there's almost nothing to stop you because you have the team willing to do the work, and it's going to be a lot easier to get management in line with everything the employees want to do if they're both aligned with business concerns and priorities. So if you can build from the grassroots, it's going to be a lot easier than saying like, I've got the okay from management, now what? And then nothing happens, right? You always have to talk to other people and convince coworkers to do that. And then use that to reassure the uncertain managers, like, oh, the entire team is behind it. Here are the names or something like that. You have to be aware, though, that whenever you switch technologies, you're going to lose people, right? If you are working at an Elixir place or an Erlang place and they're telling you we're going to switch to Go, we're going to switch to Java or something, a bunch of your people on your team are going to leave to work with the tech that they like. So the same is true when you're the one replacing another stack. You have to be prepared to lose employees who like the technology that's already there or hate the new one. And you can't pretend it's not going to happen. You're going to get much better results if you fully agree with that, and even then get a feeling of who it's going to be and how you can work around that and prepare this sort of transition plans. If you don't have that and you can't acknowledge it to management, it's not going to look realistic as an effort. It's just going to look like you're trying to wedge your pet project in there, and they're going to give you the this guy knows about that. Like, let's keep that person busy. We need them to work on another project. They're going to stay for 6 months longer if we let them, give them the hope that they're going to get Elixir in or something like that. And if you've cleared all of that, then I think that you have to set up these plans about people getting in there. So for me, there's like 3 phases. There's starting a team, there's training, and then making it safe. If you're starting a team, remote is easier. Thankfully for the pandemic, it's now easier to get remote than it was before. There's always been the problem that there's more jobs in these technologies that are employees available locally, and there's more employees available globally than there are local jobs. So if you go remote, it's going to be a lot easier to build one of these teams. Mike mentioned it. You want to build around a few experts and motivated people. Your experts should have the role of guidance, which means they might participate to training and stuff like that. You don't want them to just work alone, locked in a room, and then come back with a solution written that nobody can maintain. You want your trailblazers. That's going to be the motivated people who are learning right now. They only need to be 1 or 2 weeks ahead of other people, and they're kind of disseminating more the knowledge that the experts is giving them. It just makes the whole thing more effective or efficient. Training, you want to count and calculate how long it takes to be productive and try to lower this down. Pick a limited project, show the subset of the language and the tech stack that you need to get going. And if you can get someone to have a pull request and contribute something to shorter tickets that you've groomed for within 2 weeks, then it's going to make everything feel a lot safer. You want to hire as normal, but you want to create a path to the rapid onboarding. You'll need to hire people who don't know the technology. You're going to want to train them and turn it that way. And so your onboarding path is always going to be, we're not actually hiring experts. We're hiring people who know bits of functional programming and stuff like that. We're teaching them. It's going to take 2 or 3 weeks. And so the 2 months time to being productive is going to be 2 months and a half now. But after that, we've got our team. And making it safe is going to be essential. You always want to start with volunteers. The worst thing you want is to get people who are not interested, who are then going to, through back channels, convince people that your project is terrible. You start with your volunteers that are going to become strong advocates, and you're better starting small and then spreading out more rapidly that way. You make it possible for someone who doesn't like it to actually go back to whatever they were doing. You don't want them to feel like this is a leap of faith and a big trap. It has to be something that's easy to do. They can try it, bring back the ideas, that it can, grow in their mind a bit and say, oh, you know what, this was a good idea, let's go back to it. And be ready to call the experiment off. Like if after a while your small project is not going, you have to be okay with killing it and not just, persisting past the date of usefulness. This is going to be good for yourself, but it's also going to be good for the acceptability of the experiments you're going to want to run. And so if I want to go really quick about that, some fights aren't worth fighting. You have to pick them. Some of them are going to be easier to win. You want to focus on these. You want to address the underlying concerns of people. The rationalizations that we have are always going to be on the technical aspect, but a lot of the actual problems have nothing to do with the technical aspect. It can just be that the tech I use is now part of my identity and I don't want to switch my identity right now. And those are going to be almost impossible to tackle. Aim for the alignment within the team, within the organization, within the company. If you're trying to drag the business in a direction it's not interested in going by using new tech, it's never going to be successful no matter what you have, no matter what the tech is, it's not going to work. Orient everything towards learning. You want a learning team, a teaching team, people training each other all the time, and they're going to be really, really impressive. And what might happen is that if that works well, regardless of technology, people are going to want to know how that team is working to replicate that at different parts of the companies. Address the 1,000 paper cuts, the little pains that people have. If you're the expert or the advocate, go around every week, every 2 weeks, like, is there anything that's pissing you off right now, that's making you lose time, that's irritating to you, and be ready to invest in the tooling to fix these concerns. Some of them you can't, some of them you can, but showing that sort of continuous progress at least gets people knowing that, you know what, it's going to keep improving. And all of that kind of boils down to creating and maintaining psychological safety, which is essential not just for this, but for business in general. That's what I have for now. I think we're close to over time. I don't know how much time we have for questions.
So I just want everyone to turn on your cameras, turn on, remove the mute button and give a big hand to this tour de force by Fred and by Mike. Thank you so much. Great hands, big hands. And we have time for Q&A, so that's great. We have 5 minutes, and I'm gonna start off with one thing that comes to mind. I think this is so inspiring. There's so many good advice, good pieces of advice based on your experience from large and small companies and large and small organizations. One thing that I'm thinking of when hearing you talk about this is 10x. 10x is something that, for example, Apple uses when introducing new technology internally. They talk about if you can't make it 10x better, don't bother. So then you continue with the existing technology, whatever that would be. So your thoughts on 10x, 10x better in the sense of how many nines can you get, 10x safer in the sense of how few vulnerabilities can you find in the CVE database, 10x more in the sense of number of users, 10x less in the number of servers or the amount of energy consumption or money that you need to spend on your system. Any thoughts on 10x as a sort of change lever?
I think the problem is that people have to believe that you're actually what you're suggesting works. And if people don't believe that, you can start sort of 10x, 100x, whatever. But it's a question of a buy-in to the technology. Getting a buy-in is what is really, really difficult. So I can understand the idea of talking about 10x and all the rest of it, but I would say that the real thing is to get the buy-in, and how you get that, I don't know. But sometimes it works and sometimes it doesn't. An interesting question, an interesting thing to observe is how Sun once upon a time succeeded in selling Java. And it didn't happen by itself. They sort of went and they spent an incredible amount of money creating the brand, creating Java, creating the new way of doing things, and sold it that way. And if you have to get the buy-in and you have to get the brand.
Yeah, to add to that, like the 10x is really, really good at clearing a class of technical counter arguments, the concerns there, but they don't necessarily address the underlying one. One of the most common one that you'll hear all the time is, can I get a job doing this later? Is there a 10x for jobs in this? Which you'll almost never get with non-mainstream technology because there's a million X more people using the mainstream stuff. So it's going to facilitate part of the sale, but it's not going to guarantee your adoption, and it might look like overly aggressive marketing in there. I think Rust is going to be the interesting case study about that, because they have that 10x, it's faster in C, it has fewer security bugs and everything like that. But it doesn't necessarily give you the 10x on the user experience, which is it also might take you 10x the time to ship, because you have to fix the bugs before shipping. And what you can do with something like C or Go or JavaScript is you ship half-broken software and you fix it after it's already making you money, right? And you can't necessarily do that in the fancy tools that force you to tackle and fix all the problems before you even ship. So there's a 10x technical advantage, but it's not necessarily one that's going to translate to an actual productive workflow on that front. So some of these cases get interesting because they get very, very strong penetration into a niche area, but they don't necessarily get a high man share. They get you to be the language where people go to feel smart, not necessarily where the people go to make money. And that can stall adoption. It gets you up to a point, but it's not guaranteeing anything else about that after that.
Thank you so much, Fred and Mike. I see Ulf Viger has raised his hand. I don't know if it's a question or if it's a comment to the previous question. Go ahead, Ulf, please.
It's a little comment to the discussion about mainstream going up against the mainstream. There is a sort of a margin phenomenon that I've noticed a couple of times that I've started calling the IBM effect or whatever. If you're marketing your niche application to a large company that basically does business with one of the mainstream giants, and you are basically addressing a niche that mainstream giant may want to enter soon or is preparing to enter, they will essentially, it may seem that you are doing well until you get to the point where you actually have to you'll have to involve purchasing. Then you get up on the radar of the big giant, and they will happily stomp you without thinking twice, just to keep that area clear so that they can move into it later. And it doesn't even require any effort on their part, at least not effort that sort of makes a difference to them, that is even measurable, which if you're a startup, it still means applying more people than you have on your roster just to make sure that you don't get the business. And it's a good thing to know, and because it's a hard thing to experience. And you can think of clever ways to get around it, but it really is a true thing. I even noticed it at Ericsson once when we went up against Cisco on the US market. It went swimmingly until it got up to the CEO level, and then we found out that the Cisco rep golfs with the CEO, and that's where it stopped.
You can kind of get into a safer area if you're a small company and you're operating on small fish, right? Small accounts for a small company, which a big company would not even consider worth it, because one big enterprise contract is worth all of your customer base. And so you can build a kind of foundation on that. But yeah, it's really, really hard. Otherwise, I have to assume I've never run a company because I'm afraid of stuff like that. But yes, this is extremely concerning all the time.
Yeah, and it's so tempting to go for the big price. It's, oh, we get a business, we get a contract with them, and it will take you like 6 months to get to the point where they actually put money on the table. And that's where you end up. It's like the hidden nose. That's where you find out that your big competitor actually has veto power and you didn't know it. And it was $1,000, Mike.
So Mike, any final thoughts before we close off the Q&A? I guess we can continue it in the Toucan Lounge, of course. I'm sure there will be lots of good discussion in the Toucan Lounge. But any final thoughts or comments, Mike?
No, not really. That, as I say, that the important thing in all of this, in all technology and all the rest of it, is not to realize that it's just not a software problem in itself. It's actually a management problem. And there are so many other aspects that one thing I mentioned vaguely, which I think is probably very significant and we tend to forget about, is the brand. branding is very, very important. And if you get a brand of being wacko way out, which is one of the problems I think early on in Erlang we had, the people have said the brand was difficult because it was functional programming, and functional programming is hard, and that kills the brand. But I think we're past that now.
Yeah, I think that's a very, very good closing remark, Mike. Thank you so much. And you say it's a management problem, and for me, a management problem means it's a human skills thing, right? It's about human beings, emotions, which is scary to us who are developers and coders and engineers. We like, you know, deterministic things, and people are non-deterministic, and they have, you know, wills and feelings and stuff. And we should always remember that, because ultimately it will be people who make the decisions. It will not be, you know, a machine learning algorithms who decides what technology to use. And we need to work with that. So yeah, once again, thank you for great questions, and thanks for a great closing keynote, Fred and Mike. A big hand again.